Hey friends, welcome. This is another session where I will be discussing about the second milestone of the MLP project. And yeah, it's me Shubham, your TA for the machine learning project, where I will be teaching you the second part or the second discussing the second lectures and all for the upcoming new session. So today we will be discussing about the linear models, stochastic gradient descent, and hyperparameter tuning, which is the main agenda of your lecture 2 or milestone 2. So basically we have the following things. First of all, we need to know what is a linear model. And by linear model, we are very clear that W1x1 plus W2x2 plus Wn I think this is the base thing. Everyone knows this very well. So there are types of linear models. First is linear regression, logistic regression, ridge regression, lasso regression. These are basically four types of linear models. So logistic regression is a classification model. Linear regression is a regression model for the continuous output. I think we know this very clearly. And this is a bit example. I have created the slides. You can go through these slides well. These are the basic steps how to do and what not to do and all. We come to a special option or special name known as the stochastic gradient descent. What is a stochastic gradient descent? It's an optimization algorithm used to minimize the cost function. For example, if we are using the normal linear regression, there also we are using any cost function or the function where we are doing this gradient descent and taking that negative like subtracting the value and doing the following things using that like this one wt plus 1 is equal to wt minus like updating the weights. For updating the weights we are using the algorithms. For such algorithms we are basically using stochastic gradient descent, and it can be of different types. For example, batch gradient descent. What does a batch gradient descent means? For example, we are sending data not like more than 32 at a single time. Like basically what happens, 32 data are averaged down and sent over there. Stochastic descent is a type of that only, but where each individual dataset is passed one by one. And mini batch is obviously something which is between the batch gradient descent and the stochastic gradient descent and the best among them. Okay, so for our study we will be focusing on stochastic gradient descent only for till now, because that's there in the milestone, and I think everyone knows this formula very well. Yeah, hyperparameters. Okay, let me tell you or clear you something about hyperparameters. Hyperparameters and parameters, these two are different terms. Hyperparameters are something which we define and we can change, and parameters are not something that the machine decides and we can't change it. The parameters, simple. Do not confuse with the mathematics parameters or the Python parameters. These are different. So next we have, so there are different types of HDT over there. Next comes to the hyperparameter tuning. What actually meant by hyperparameter tuning? So hyperparameter tuning is something. So let me break the word for you. Tuning. What does the word tuning means? Refer to fitting to correct values. That's tuning means. When we tune a guitar, so it's basically tuning the guitar means we are putting the notes in a current texture or in a current format to sound well. So tuning is that to get the best output of the model we tune sometimes. So tuning can also be referred to as refining the model and all. So unlike model parameters, they are learned during training. Hyperparameters are set before training begins and control the learning process itself. So you know how the things comes, and we have the, yeah, it's a very good example where I have made the common hyperparameters. There is a learning rate, batch size, number of epochs, regularization parameters, momentum, and optimizers. There are many things like HDD, ADAM, and RMS prop. ADAM, RMS prop do not go over there. It's for higher level of things. I have just given an example over there. This is for your Viva preparation, because you also need the Viva to be clear by your side. So this is the Viva part. Just go through them because this is an important topic where questions may come. One more thing is cross validation. What does cross validation means? Like suppose we are doing something and I want someone to check my results. So we are doing a cross validation. Like check my results. Someone is checking my result and validating me. Someone is checking and validating means basically means cross validating me. So Cross validation has many advantages. One of them being it gives you a robustic idea how your model performs on unseen data. It will jumble things up and all, then provide you the values over there. So cross validation is a part of hyperparameter tuning. Make this clear. And yeah, obviously for hyperparameter tuning, we use grid search implementation. You can go through this. I have made into a single chart, but I will show you the codes in a bit. And next we are going for the manual hyperparameter. Yeah, so we are doing this part. Check this part. So we are doing the manual hyperparameter tuning with validation set, how to do and all. I have given a full types over here. So don't worry. I will be explaining these things over you, how to code well and this. See, every part, everything. For example, you are going for cross validation or something. Everything you can't memorize, or everything you may or may not of like you will forget such hard type of codes. But how to do? But how to do and how to deal with that? Let's see. So for you, I have prepared this. See the session timing. I have been working with this because of hyperparameter tuning. It takes times, so it's a time method. You need to give the time machine the time to work on this. So basically, what I did, since I am just working on this, since I am working on the past 1 hour on this. So let's see what we can do. So first of all, basic things, we have imported the data, imported logistic regression, SGD classifier, rich classifier. Again, I am showing you the trick. For example, you do not know what is where from where to import what. Just simply go and type this import sklearn, then dir actually I'm defining the code. What is dir refers to? Dir refers to directory. So I am just taking the sklearn directory. Let me see. Can you see the number of things over there? Many things will come over here. But we need what do we need? We need a linear model because we need that over here. So here we see a linear model where the linear model is. Let me find. Yeah. So there is a linear model. So just copy. I'm just copying this and I am doing this part. Just see the trick. See, under the linear model, we are getting such type of things. Lasso CV is there. But what do we need? I have again told you, just go to the slides again, like make the video pause and go back and check that where I have told that in the linear models, we actually have four types are there. Linear regression, logistic regression, and lasso and ridge. So lasso and ridge are basically penalty parameters, right? So here we will use, like, this is the classification problem. I think you are very aware of that. What we should use? We should not use linear regression because linear regression is for regression types of data, and logistic regression is for logistic or classification type problems. So here I will obviously use this logistic regression, SGD classifier. Obviously SGD classifier, not regressor, because two types are there. Let me show you. This is a classifier one. This is a regressor one. Do not get confused on this. So classifier I will use, and rich classifier I'm just given here for example. I will not use that because it doesn't require for that. So you are having this type of things over here. You can check that thing anywhere. And yeah, and one thing that you forgot what to do, like what to do with the codes and all. That I will also come. Next we are okay. I am just telling my way. I have just gone and checked the trend df.info. What I did, I just build a basic model where I removed the religion, race, gender, disability. Why? I am just telling you why. Because these are all object type, and you know very well object types are not acceptable for model training. Either we need to convert it, encode the characters and all, and do the following stuff. So for that reason, I just made a simple thing. Just go through the training data and just dropping by the drop command. So I'm just dropping all the uh, columns where it is of object type, boolean type, something not a integer type. So I am just keeping all the integer type. You can see the code very well. I am giving the reason over here, keeping the integer types only. This for demonstration. In your actual data or the milestones which will be provided to you, there they might not, they obviously tell you that what to do, like remove the religion or impute the religion, something type things, and then do the following things. Yeah, they can tell. I'm just showing you the concepts, how you can go to the concept. Next, we are again, you know this beginning step very well. We have covered in the first class. External and white these are two types of things, and I am just doing the very similar thing. I think you should be habituated of this. Then we are coming on model selection. Okay, since I have practiced so much, so I know where which API contains what things. So obviously for these things also you can go and check like this, dir sklearn. So you will see here model selection is over there. Like you need to obviously have a check or go through this, then you will understand, then you will get the habituations. So under model selections I will get this thing, trend test split. Let me check where is it. Yeah, see, trend test split is there. I have used this for splitting my data set. So again the splitting is over here. I have done the splitting, and here I did a small thing, that is I have taken the metrics over here, and I have just used a dictionary to create a single variable for my models, just a programming practice. You can also do yourself also, no problem in that. So what I did actually, so I am just running a loop and checking the models and all. I think you are very aware of this, how to take these models and all. And you see what I have done over here, it was actually, it gave me the following score. But do not get happy with the scores, because this is basically the score where I have used the average equals to weighted. But it is not that true, because the class is highly imbalanced. In the previous lecture, I have discussed about that. It's a highly imbalanced data. If you see, you will get to know. If you tell me how imbalanced, I'm just showing you the things. Like if I give this code 10.df, let me check. Yeah, it's there. So what I do in the trend.df, I check the not this area. I think it's not this area. So what I will do, I'm just showing. So I will just do these things. Just wait. 20f.info is there. Yeah. Before this column, because I'm dropping this, what I will do, trend df. Yeah. So trend df dot trend df of, I will use this one. What is this level? Yeah. Level is this one. Dot value counts. I think you are aware of this. See the imbalance in the data. So zero is highly um induced in this data set. After that two, then three, then one, like two, one, then three. Everything is given over here. So it's the imbalance data. This shows the imbalance in nature. This shows the imbalance. So I have used their weighted, nothing more. Yeah. So after this, I have done these two things, and after this, yeah. And this is the thing where the things end, and this is the hyperparameter tuning, and we'll discuss now. I have explained you the concept, what is hyperparameter tuning. Here we will obviously import this grid search CV, which is a main thing for hyperparameter tuning. And let's see what to do. There are two important things. Like I also did not know. I also may forget. So what I use a question mark and searched over there. What is a grid search CV? Then I got to know that okay, the parameters are over here, estimator, parameters and all, and I have gone through the strings and all and checked the things over there. So after this is a documentation. You can also go. I have just used this for your understanding on things and all. So here what I did the hyperparameter tuning. So here the thing is, you need two things, param grid and estimator, two important things which is must required for a uh, model to perform, because this is the parameters things. Then coming, how do I fitting how do am I fitting the data? So I am fitting the data as extra and white, and I think you are very aware of this, how to do this. Just take the name. This is a model G, this is a model G. I have used a different name to understand. Yeah, and this hyperparameter tuning took up more time, because it is a hyperparameter tuning. See, you can see my number, how much time the session is going on, 1 hour 10 minutes. So it's quite long. So I have used this technique for the hyperparameter tuning. And always in your notebook, do a habit of doing these things. Just copy this and commenting things out, because this will be useful for your plagiarism check. They will check that. If you've done the hyperparameter tuning, they will check that. So remember to do that. And you must be worried about why I did this. So what is the use of hyperparameter tuning? To get the best, to basically get the best parameters. So by using this attribute, so this is basically an attribute of model GR. So this is basically an attribute. So by using this attribute, I am getting all these values: logistic regression, C1, solver, saga, tool 001. You can check over here. I have given two values, but out of these two values, only one is being taken because that's the way how hyperparameter tuning does. After that, I use this values to train my model, and I got this score again. This was a demonstration of hyperparameter tuning. Here you can use the cross validations and all. So I have given you uh, like the enough proof of how these things happens and all. I think you should go through the theories very well. My recommendation should be go slowly. Everything you will not remember. So I have given you the techniques how to check the documentation in that code only. This would be applicable for you in the viva also if you get trapped anywhere, and this sort of things are allowed in a type of viva to see the documentation and all. Because if you check this very well, this is too big, everything you can't understand, too big to understand. Like only the grid search CV has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 parameters. It's hard to remember. So focus on the concepts, how I do the things and all, and go on. Yeah. So that's all for today's class. We are like ending this session, and we hope for a better class next time ahead. And this is a recording version. Don't worry. If any doubts, please tell me, and I will be there for this help and all. So thank you, and I am saving this recording. Good night.